Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Integration consideration. What's your agitation? As a professional developer, you're eventually going to have to work with a third-party service. Other people's systems can introduce very interesting experiences, especially as your interaction with those systems matures. Not only are third-party systems opaque, usually poorly documented, and often subject to change on short notice, they can also play havoc with your own release cycle. In this episode, we'll talk about some practices for working with third-party APIs without the constant risk of nasty surprises. But before we get into it, Will, what have you been fighting this week?
Well, I have been working like a dog. Just with the book and everything else going on, we've got a lot of stuff to do for the podcast. I've got a lot of stuff going on at work concurrently, like multiple projects that I'm on. So everything has been pretty crazy. One of my neighbors had heart surgery earlier in the month. And so we set up a meal train. This weekend was my weekend to cook. So I like to overdo it when I do this. I don't do it often, but when I do, I really do it. So I made 2 pans of lasagna from scratch, made a vegetable casserole, like a potato and pepper and other stuff, casserole from scratch, 2 loaves of sourdough bread, an apple crisp, and a garlic butter spread for the bread. And I got them all done and walked to the front door going, okay, I'm going to take them over there. And it was pouring down rain. Nashville has had an unbelievable amount of rain here in the last week. I forget what the amount was. We've had some roads that have gotten closed, either due to actual damage to the road or to parts of the hillsides above the road ending up on the road. And so we had this just ridiculous exercise of trying to get the food across the street. Like, it's less than 100 yards. Really tricky to carry a pan of hot lasagna and an umbrella at the same time. And so it was an absolute circus. But we managed to pull it off. That's basically it. Like, that was probably as close to not working as I've done in a while. Yeah. So how about you?
Well, I finally got a minimum viable product for that .NET Core console app that I've been talking about. Actually, today, I was supposed to do it yesterday, but the ops person that's going to be managing it, they had to unfortunately put his cat down, like 19-year-old cat, and so he was out for the day. Him and his wife were just sort of doing their thing, and so we rescheduled it for today. But it was cool. I got to show what I've done so far. Now, it didn't have everything in it. It was just the core functionality of what I needed it to do. I still have several things to do on it. To really get it tested and polished and things like that. Unfortunately, I've been pulled from that project and all of my other projects to put out a few fires.
Sounds familiar.
It's a bit crazy, but hey, job security, man. Now, school has got me busy. My midterm is coming up. Well, by the time this episode comes out, I'll have already taken it. Still, it's been a few years since I've really taken a test like this, like a school test. Last semester, we just had assignments and no tests. I'm a bit nervous. I have to drive down to Chattanooga, which is about an hour and a half or so from my place, to the school to take the test. And, I have been studying, like, just doubled up this past week. I'm even watching the lecture videos again while I'm on the treadmill at the gym. Speaking of going to the gym, I've got something fitness related for IoTs. Tangram Factory's IoT-enabled jump rope has LEDs embedded in it that displays the number of jumps you've made in front of you while jumping. It's really cool. And instead of using something like vertical acceleration or vibration, this jump rope measures jumps by the rotations of the handle. The smart rope allows users to set workout plans and log the repetitions, and kind of even gamifies workouts by allowing people to compete with other smart rope owners. And the ropes can track progress in a free smart gym app or connect with a lot of other devices. It's pretty neat for the athletic IoTeaser. I have a link to it in the show notes. Who's talking to us this week?
Well, we got a comment on the code reviews episode from Jacob D. I really did like this episode. Just started working for a new company where code reviews are optional. In fact, I did not have any official review yet, working here for about 1.5 months. So I'm planning to get code reviews on our agenda, but I know it is going to take a while to incorporate it in the process. Thing is, I'm very used to just asking any developer around to come sit next to me to do some code review. So that's what I've been doing now. Just setting an example, I hope, show them I do not fear their opinion about my code and that I'm willing to A, learn from their views, and B, teach some new things I've been doing. Some developers already started doing the same, so I'm getting the ground ready for code reviews. I did not get them to listen to this podcast, though. Aren't people lazy sometimes? I told them my dishwasher has been broken for about 2 years now, so I use the time I'm washing the dishes to watch Pluralsight or listen to podcasts. The looks I got, just priceless. One thing I have to disagree, though. Why should I not let our customers pay for code reviews? It's them that benefit most. More developers know the code, less bugs, and cleaner code. Anyway, keep up the good work, enjoying your shows while washing the dishes or riding my bike to work. Okay, so the point of what I was saying on that was not to put these as a line item, right? Your customers should still pay you for the time. It's just that when you put it on a line item, the customer doesn't understand the value of what you're doing. And so they think that if they cut that out, they cut that expense out. And as a professional, you've got to be very careful not to give people options where they really shouldn't have options, because they'll make bad choices. And some of those choices can lead to a reduction in code quality. They may try to nickel and dime you to death if you do that. It's sort of the kind of thing like if you have a doctor, the doctor bills you for certain procedures. They don't break that down into tiny little pieces like, oh, well, I sterilized the instruments for your surgery and that cost this much, because there'll be some guy that will come in there and say, well, don't do that. I'd rather have the $5.
It costs a bit more to do that. And some hospitals actually do charge you for that.
Yeah, but usually you don't get that broken out in the bill, right? Like I've never seen instrument sterilization on a bill. Like the individual operations that are of value to you, that is what gets on an itemized bill, or, materials. But just be careful about how you do that. That's kind of where I'm going with that. Like don't give the employer or the client the ability to tell you how to do your job and to tell you to do it poorly.
Thanks, Jacob. We love hearing from our listeners, especially since y'all hear from us all the time. Send us an email with your contact information, because we've got a complete developer water bottle just for you. Guys, if you'd like your very own complete developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, Twitter, LinkedIn, and I think Google Plus is still around. We also are on Instagram and Tumblr. You can check us out each week on Facebook Live, where we talk about what's going on in the tech world and answer some listener questions. Or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Third-party services are here to stay. Not only do they let you reduce the amount of work that your team has to do, but they also offer integrations with other software on the web that your company may want to use. As a result, you'll eventually have to work with some third-party software, whether it is a payment processor, an email service provider, or even a CRM for your sales team.
The initial integration with most third-party APIs is usually pretty easy, but over time, you'll learn that there is a price for being too tightly integrated with people outside your organization. Third parties always have different goals than those of your organization, and you need to design your interactions with their systems in a way that protects you from the consequences of their goals. Done properly, you can not only protect yourself from bad behavior on their part, but you can make your own systems more resilient while doing so.
In this episode, we'll discuss some things to consider while integrating with third-party APIs. We've broken these considerations into 10 rough areas that you should think carefully about when designing your next integration.
First off, we're going to talk about error handling. You will encounter errors when integrating with anything. Many of these may not even be your own fault.
Yeah, this is something you learn the hard way when you do this for the first time.
Yeah.
APIs upgrade or change implementation all the time. And a lot of times the docs don't really keep up with that, and you don't get told. It just one day stuff is busted.
Yeah, I don't know that the docs ever keep up with that.
I think it's possible for one to do that. I don't know that I've actually ever seen that happen. Let's just say that it's bad. The other thing is you'll get network failures, right? You're calling across the open web. You know, sometimes a router is going to be down somewhere, or, you know, they're getting DDoSed, or, you know, whatever's going on. Like, all kinds of stuff can happen to their network or to your network or some network in between. We've had incidents in the past where, one of the generators wasn't working in a data center, and then somebody clipped, you know, the power supply to the building, and then something else happened. And, you know, like, you can have a chain of events that occurs where you get an error. Basically,
you have to be able to recover from errors. I know this really got me, and it's not even dealing with third party. It was dealing with an internal service that was, they had an MVP out there, but it was still being fully developed.
Right.
And they didn't have a separate dev environment for that. They were in the same dev environment as me, meaning when they pushed stuff up on that team to test it out and to see if it was working. And yeah, sometimes you break things in dev to find out where they're breaking.
Yeah.
It broke everyone calling that.
Well, and that's the thing too. Internal APIs are way worse than external.
Yeah.
Because people are lazier.
Yeah. What I'm getting at is that's when it really hit me that, anything that is not in the app that I'm writing, I have to be able to recover from its errors, right, internal or external.
Yeah, and the big thing here too is that you need to build in retry logic, you know, from the get-go. Like, you have to assume that your stuff is delivered at most once. Well, at least once, and at most once, right? Like, it may never get there, or it may get there twice.
Good point.
Yeah, and that's something that's kind of hard to learn, but you might as well, you know, start with that. The other thing is you don't want to fail and then immediately retry, right? Because, you know, let's say you go, okay, I'm going to allow 5 retries, but that happens in the space of 10 seconds while the network is out. Well, that's not useful, right? So
that makes good sense. Yeah.
Yeah. So basically, what I've done in the past is say, okay, after the first failure, subsequent failures are essentially using an incremental back-off model. So usually what I'll do is I'll say it's 2 minutes raised to the power of however many failures.
I like that. I would wonder how to set that up, because I've been thinking about doing that in something I'm working on. And so that I like that. That's good.
And there's a reason I do that, right? Because a lot of people will initially do this and they do it linearly. In fact, I did that once. But what happens is, as an outage window goes longer, the requests that are waiting pile up. And so all of the service comes back online, stuff isn't going to be optimal on that end, right? Like, caching's not there yet. Maybe they've only got one machine in the load balancer instead of 4. And what did you do? Oh, as soon as it turned on, you carpet bombed them.
Yeah. Okay.
And then their service goes down again, and you get to experience the same thing. And then they cut you off because you keep knocking them offline. And they're like, well, we'll let that guy catch up after everybody else. And so this keeps those from piling up in the same time slot.
Interesting. Huh. Also, errors on their side should not break your code. Any updates from them should be treated in an idempotent fashion.
Right. So if you get the same update twice, what happens? Right? You should have some way of going, okay, this is the same as a previous one, and not executing the second one, especially if there's, financials or logging or regulatory compliance. Basically, pretty much never. because that will make your system incorrect, essentially.
Well, it goes back to like the same concept as disabling the submit button once it's been clicked.
Right.
Webhooks on your side should also log errors and send an alert if the errors exceed a threshold.
Right. And for this example, I'll tell about something that happened to me. We integrated with Mandrill, which is MailChimp's transactional mail client, right? So we can send emails out through that. After they've sent, Mandrill will call back into us. They call on a webhook and they send us a post essentially. That's like, hey, here's the stuff that's updated. That's all well and good. And they retry, by the way, too. So if they have something funky happen, you could have the same payload come in twice. But the other thing that can happen is they're doing a forum post. And it turns out that if you are intimidated by using stuff that's, past about 2008 on the .NET framework, like, I don't know, anything other than web forms, then you just go, well, I'm just going to implement this in web forms and read off the request. That's great until they include HTML in the payload. Then it thinks it's a cross-site scripting vulnerability and ASP.NET will kick it out and it fails. And when they go, hey, let's send this payload back. Well, dude was testing. He was testing with raw text. All of a sudden, we online the ability to send HTML out through one of the channels and somebody turned it on. And we had multiple clients start breaking all of a sudden, right? So you don't, and we didn't know as quickly as we could have. So like you really want to have an error threshold and get a warning quickly before people start screaming.
Yeah, what this makes me think of is I was connecting to a service for file storage.
Yep.
And the way it was written would return a string of the GUID, the file that it was storing. But if it errored, it would still return 200, but it would return the message of the error in that string.
Yep. I love that pattern. That's, why do you really need HTTP status codes? It's always 200. It's 200% right.
So you know how I dealt with it? And I thought this was creative on my part, at least, is I get it back and then I try to convert it to a GUID. I wrap that in a try catch. And if it won't convert to a GUID, then I take that response and I put it as the message. And when I throw a new error, yep. So that my code will error when they, and I can handle that properly.
Yeah. And you've got to assume that if you're calling somebody else's web service, that they don't understand HTTP because they might not.
So the next one is diagnostics. You need to be able to get useful debugging information from your integration points. Now, this means being able to see responses from the API as opposed to whatever you're turning those responses into. This is right along with what I was talking about.
Yeah, exactly. So if you were turning it into a GUID and you're like, I'm going to save it. And I had an empty try catch block or empty catch block and then just go, well, this will be an empty response. I can't see what's in that actual payload coming back. And I really need to be able to diagnose what's going on. Because they may decide, hey, we're going to send, your license is expired. And you might really want to know that. So you need to have some ability to get at the raw data that's coming into your system before you transform it into something else. And that means that you got to have sufficient logging, including how long a request takes to process. Because you need to know, hey, we can only handle a certain amount of load here.
Also, you need to be able to determine if your integration is incomplete. The other API may change without you knowing about it. And this can mean new responses, new error conditions, and new error codes.
Yeah, or they just didn't document well. That's the other
there is that too. I've run into a lot of that.
Yeah.
Especially when you're using open source stuff.
Yeah, or payment processors are real good for that. Just sending you something back that doesn't make sense. It's like, oh, this is a new error code that I've never seen before. It's not in the docs, whatever. And if you're not handling these appropriately, you'll notice that your system over time starts failing more and more frequently.
If you are logging appropriately, you'll be able to see what the API is sending you and determine what happened. And this goes back to what I was talking about. I knew that they were sending the message from their error back with a short stack trace in it too. So I just put that as the message in a new error. So I was logging their error on my system.
Now I will throw one other thing in there real quick. In .NET, if you're raising an exception, try not to wrap other exceptions. Like, in other words, you get their exception. Don't wrap it in my API is screwed up exception and throw that, because a lot of people's loggers are kind of crappy and they don't get the inner exception. And so you go, Entity Framework is a prime example of this. Something went wrong in the database. I know it's an Entity Framework error. Basically, I would rather them just draw an ASCII representation of a giant middle finger, because it would be more useful than the actual message that they give me.
It's not just Entity Framework. It's all ORMs. Every single ORM that I have used does that.
Yeah.
They're like, some error occurred. And it's like, okay. And you have to drill down.
And you got to know the address of the error, right? Because it's like 2 inner exceptions in, and then you look at the exceptions in that aggregate exception, and it's the third one. And you're like, really?
Right.
Like, that's not...
Honestly, we work with Oracle, so I just look for the Oracle error code.
Yeah.
I'm starting to learn some of them, because I'm like, I recognize, most of the time, I would say probably 75% of the time that we get an error from Oracle, it's, a new table or view, and we forgot to put a grant in for it. That is the majority of the errors I get from Oracle are, permissions issues. But anyways, that's why when I started integrating logging in my stuff, I always make sure, because I built the table that we logged to, I'm like, I put an inner exception in there, and I can get all of that.
Yeah, but I mean, you just really have to be able to get at whatever's useful, and that would include statistics, right? You need to know how many requests that you're sending and the stats on the results. So if you're seeing, hey, 14% of our messages are failing, you kind of need to know that.
I mean, at some point, your app scales. Your integration points will become a bottleneck, and you need to know when that happens. External integrations are easily blamed when a system gets slow, so you need to build proof in from the start.
Yeah, and you'll learn this on development teams. They like to go, oh, it's this third party that screwed it up. But what ends up happening is the blame lands on the developer that wrote the integration, even if it was the third party. I've learned that one to my sorrow repeatedly.
So next are outages. Your network will go down or be under maintenance at some point. Even the best data centers will have the occasional outage. You can't spend your way out of needing to handle this problem.
Yeah, you have to test from the get-go how the system is going to react to a failure. You might be surprised by the consequences of your assumptions. And so, like, for instance, an email service, you might go, well, the email can send 30 minutes later, but what if it's a password reset and there's a timeout? Now you send a bad one. Just all kinds of little stuff like that you don't ever consider jumps up and hits you. Now, the fun part of it is it's not just your network. Their network will also not be working at some point, right? The API that you're calling, it's going to have an outage, intentional or otherwise. And you need to have a mechanism to retry any calls that can be retried and then gracefully fail on the others, and the ability to tell those two things apart.
Yeah, you may want to consider using a feature flag to indicate whether a particular service is usable to keep from slowing things down, such as web server threads getting tied up, making calls to external services that are timing out.
Yeah, because that can take your servers down, right? Like it's trying to hit that external API, and it eventually runs out of threads in the thread pool, and all of a sudden you got bad problems on your site.
You also need to think about how both sides catch up on processing after an outage. Once the outage has stopped, you still have to catch up processing.
Yeah, and you need to make sure that you don't immediately throw a ton of work at the API. That's why I talked about the incremental backoff earlier. And this is especially true, by the way, if the results of the work that you're dumping on them come back to you from them, right? So it may be like, hey, you can just dump a ton of stuff on them and they can process it, but then they send it back to you and it's more than you can handle because of the downstream reactions in your system. So basically, you build up almost a standing wave of work that's about to wash over the top of you. That's really, really unpleasant because, they may be hitting, webhooks, for instance, on your end and just absolutely saturating your system in a way that you didn't expect. Because most people don't test their webhooks for load very well.
Mm-mm. You think about security. you probably don't want anything connecting with the outside world from deep within your network.
Yeah. If it's a home network, okay, fine. If it's, I don't know, a bank,
Yeah.
a defense industry thing, yeah.
Government.
Yeah, they're not going to allow that, right? They're going to want the stuff on the outside to live either on an app server or on a web server, right? But you're probably talking web server for this kind of stuff. And then it's going to have to call something interior to the network, which is probably another server. So like, for instance, if you're doing, some, PHP apps, for instance, right? You'll have Apache out on the edge. You have your website running in that, and then you're calling to Tomcat for your app server, and then that's actually talking to the database. You don't make the call direct from the website to your database because of all the SQL injection fun and what happens when you get DDoSed.
Yeah, this is why a lot of your network admins make sure that there is a firewall between your web server and the internal network with the sensitive data. If your main database has data of a sensitive nature, your webhook or API integration point just became a huge target for a breach.
Yeah, and guess what? Your database has sensitive data. Just from a GDPR perspective in the European Union, from the perspective of having your client contact list in there, there's so much stuff, like you're unlikely to actually need a database if you're not storing something that's sensitive.
Basically, what we're getting at is that webhooks and services interacting with external APIs need to be on app servers in the periphery.
Yeah, and that's usually your DMZ.
This tends to mean limited access to things internal to the system. This may even mean separate databases or other required servers. I know I've seen setups to where the UI talked to is basically like a doorman kind of API that just said, oh, hey, yeah, you're authorized to pass further.
Right. And it'll pass it to other APIs on the back end or to, a message queue server or a database server or whatever. It's not really the back end. It's in that DMZ, and then something else actually moves it. You're basically decoupling the outside world from your database server as much as possible.
And I've seen it to where, like in sort of a microservice type architecture, to where you have all of your different services have their own APIs.
Right.
On the, so once you get inside, once a message gets to the internal server, to the internal API, then that API talks to another internal API that talks to something on the DMZ that then talks to something outside. So it's like many layers down. And then even on the inside, it's not the specific API or app talking to it. It's talking to its own service internal. Right. So if something breaches there, it doesn't get everything. It only gets that one little bitty portion.
Right. And the fun part of this is how you deal with errors, how you deal with latency. Right. Like you have to have completely different patterns when you start scaling some of this stuff out.
The other thing, too, is you have to think about what happens if you get a breach on the other side. Like I just talked about protecting your side, but what happens if it's on their side?
Right, because they're calling into your system, right? And it could be a targeted breach. Some hacker may say, oh, they're using this email service provider that calls back on a webhook. I think their webhook is insecure, so I'm going to try to send something in that is going to make that thing blow up. And it's entirely possible to do that. Now, it's not super easy, but, like your average garden variety hacker is probably not going to do that, but your government one, yeah, you should basically consider the timing of a breach to be a question of when, not if, because it is going to happen at some point.
Well, this means careful auditing of the data held by the API, the data held by you, and the data going over the pipe between.
Right. In other words, you don't want them holding stuff that's really sensitive if they're not taking the liability for it, and vice versa, right? Like you don't want to keep PCI data or private health information on your system if you don't want to do that.
This is why a lot of companies use third-party APIs. They'd rather not have the sensitive data and the liability for it. I've seen places that use a lot of financial APIs are very popular because it's much easier to pay to use a service that handles all of your financials for you and your billing and stuff than to have to do it yourself, because then you don't have to store that information.
I would much rather, send it to somebody that has armed guards at their data center instead of to my server in the closet. right? Like that's just common sense. It's way cheaper to do that. So the next thing, speaking of needing armed guards, is their update cycle. The third party does not care about your schedule at all, and they probably can't be made to.
They probably don't know anything about it, really.
Yeah. So let's say that your clients are tax preparers, which is reasonable, and it's in the U.S. April 15th, everybody's got to have their stuff in, except they've been moving that deadline around for the last few years for some reason. Well, let's say that you're using a third-party API. They may decide, hey, let's have an outage window and an update on March 30th when all your clients are completely crushed by their workload. You've got to deal with that problem. And you may have to be ready to quickly patch your system and test it, by the way, to handle any surprise changes. That also means making your integration point fairly thin so that you can do that. It doesn't need to be doing a bunch of business logic. It's just like it gets stuff in and out, and that's it.
They may even have a reasonably sane deprecation schedule for their APIs, but if your clients control patching, you might still have a bad time. This is why you really want to abstract as much as you can. So I know we just published the episode on dependency injection. We talked about interfaces and whatnot. Well, if you abstract that out for your clients, then when they're calling into your service, you can adjust it at that point. I've had to do this where I updated a service and it was, we're changing the data model.
Yeah.
And we still have things out there that haven't been updated yet. So we still need to be able to take those in. And that was an adventure.
What's more fun is when they when they're white labeling your app. Ooh. And they're actually running it on-prem in their data center. And they're like, you can't update until after this critical window. But the API vendor's like, yeah, we're deprecating that a month before. And now you get to be the go-between and go, well, you've got to update it or your business goes down. That is unpleasant, big time. Now, the other fun thing is you have to be able to find out when a update is coming. And the ideal way to do that is not, when stuff stops working. So you need to get on their newsletter and their email list. I know developers really hate giving out their email address. This is what your corporate email address is for. Sorry, you've got to get on there, get that information, because if you don't, you're going to get nailed and it's going to be, messing up your vacation.
If the API is critical, you probably need to take the time to participate in their beta program so that you're better prepared for changes that come along. If possible, you should also cultivate some technical contacts at the API provider.
Yeah, and some of them are a little harder to do that for. For instance, like MailChimp / Mandrill. I've never talked to a person from over there at all, and we've got clients running stuff. I mean, it's working, so it's fine. But
we were like across the street from their offices.
I know.
A couple of times when we were down in Atlanta.
I know, and I thought about just walking over there and going, "Can I talk to your devs?" But I thought that would be kind of strange. Plus, it was on a Saturday, but
that doesn't mean they're not there.
Yeah, that's true. The next thing that you need to make sure that you know on this is you need to know how long they keep a deprecated API around, right? So you don't want somebody that changes within a month and, we've completely changed the object model and the old one's not working anymore. More than likely, you can't roll out that quick.
Yeah, this is something that you really need to know and consider before even choosing to work with their API. No matter how good their API is, it will be extremely painful to work with them if they are constantly breaking your stuff all the time.
Yeah, aka integrating with Facebook in the early days. Holy cow. Like their corporate thing was move fast and break stuff, and man, they did. They would hit our systems and we would just have to drop everything and go fix the Facebook API, which, by the way, there were no docs. So you would have to see what the JSON payload was and then adjust your code. And then you fix it and you push it out and then something else is busted because now that that's fixed, this other thing works. And you just played whack-a-mole for a few hours and then you're back to good. Like I did that all the time. I also went to a forum where they had a voting scenario where they're like, whose API is the worst to work with? Facebook won, clearly, because everybody was having the same problem. But the first comment on that was Facebook is only the worst API to work with because there's no word that means worse than worst in the English language.
Okay, yeah, I buy that.
So there were some very unhappy people. I'm assuming that they've gotten better now, probably. I don't know. I won't integrate with them again if I can help it.
So basically, when you're choosing APIs to work with, what you need to do is make sure that their deprecation cycle, like the length of time between breaking changes, is longer than your deployment cycle. So you deploy more often than they break things.
Right.
So since we're talking about your deployment cycle, the next point is that you need to consider your update cycle. Third-party integrations are often poorly tested by you, not them.
Don't fall into the temptation of thinking that your integration point is still working because nothing has changed, air quotes. Yeah, some API vendors will roll their updates out to the development environment ahead of rolling it out to production. And if you're not testing against that, you may have either gotten an update that you integrated and you think nothing changed, but actually something did and you're just being sloppy, or something is about to change on their end and you're about to get nailed by it.
So, and this may just be because I had to deal with an internal service I was using being developed on the same dev box that I was developing on. And so I couldn't, they would put out breaking things trying to work on it. But it just seems to me like your external environments, what goes out there, should all be the same. So if you're rolling something out, it needs to go to all environments at the same time so that people who are talking to it can know. And now it's different if you've got like beta testers and stuff. That would be like a different type of environment almost. But, I need to know that what I build in dev and talk to you, your dev server is going to work in production.
Right. And that's why you should version your APIs. But a lot of them will actually roll stuff to dev ahead of time so that they can break your dev environment so that hey, I got to fix this. But they're assuming you're testing.
I mean, I get that, but it's just that needs to be in the contract, really, if you're going to do that.
Yeah. Well, and that's the other thing that's kind of weak is integration contracts don't really happen a lot of times. And they kind of should because there is a lot of money on the table.
Now, weird things can happen during maintenance. You got to be careful. You might do well to disable external APIs until you're sure that your changes don't have any side effects that you didn't anticipate.
Yeah. For instance, you're migrating some database tables and you screw up and you get a Cartesian product and insert into another table that's used to read to push stuff to the API. And now you're sending them 100 million requests and you're getting billed for it.
That's rough. If you do take the API offline during your maintenance window, make sure and follow our previous advice about how to recover from network outages.
Yeah, because it kind of is one. Well, not kind of. It is. There's no kind of about it. Like you shut it off. But people forget, it's really easy to go, well, I turned this off. And when I turn it back on, there's no problem. It's like, that's not any different than electronics just turning off and coming back on. Like it's still the same problem space. So don't forget that one.
What happens when the API expects to be able to call your webhook during an outage?
Yeah, that's another fun one, right? You've shut the webhook down. They can't call in. Most of the time, what they'll do is they'll go, okay, I'm going to retry this request because they're using that integration pattern. So they're going to wait a little while and they'll try. Some of those people that are calling your webhook don't understand incremental backoff. Right. And they're going to do it linearly.
I would just assume that they don't.
Yes, because you don't want this hitting your systems too hard. Mm-hmm. So be prepared for that. So you got to get things back up as quickly as you can so that the wave of stuff coming in is not over the top. Now, some APIs will simply discard failed requests and they don't send it again. Mm-hmm. So you may actually have to make a call to get those. So you may have to look and go, which of these have not come back in? I'm going to have to make a manual request for these.
Now, other APIs queue and retry failed requests. This is what we're talking about. Yeah, you don't know how they're going to do that. And they may come in eventually, but might be out of order.
Yeah, because they did an incremental back off and the one that just went got a 1 minute back off, but the one that went a while ago has got a 32-minute back off. And so it's way later, but it actually came first.
A period of extended downtime for your API integration point may result in your system getting hit hard when it comes back online. And this is kind of really what we're getting at here. This can be especially nasty if things like caching systems aren't already hot when this happens.
Yeah, like this is probably the last thing you should turn back on. The next thing you got to think about is rate limiting. Now, we talked about, turning off external calls because of cost, but there's another issue here too. Most APIs are going to limit the number of calls you're allowed to make within a certain period of time. They don't want to have other people taking their systems offline when they're being spammy or they don't understand how a for loop works. You're on the open internet, like all kinds of things happen.
This is even true of development systems.
Yeah. The other thing too with development systems, by the way, is if you're putting an API out there, just as an aside, use a real server for that. Please, don't get an e-machine from 1996 and put that out there as your dev server and then have a rack of servers for production.
Yeah.
That's really miserable.
You may be limited on how many calls you can make in a short time period, or, as we've discussed earlier, build for an excessive number of calls.
Yeah, and honestly, what they'll do is both, probably. Yeah.
When making a call, you need a clean way to determine whether you are over your limit. And this gets tricky with multiple processes sending and receiving data. And you'll probably want to stop a little short of the maximum.
Yeah, because you may be wrong. I mean, there's going to be a certain amount of, either they miscalculated on their end, you miscalculated on yours. It gets really interesting trying to figure out the algorithm for how many calls have I made in the last hour reliably, because by the time a query comes back, it's already wrong.
Rate limits can often result in calling failures.
Yeah, thankfully. You'll basically get a response back that just says, "Yo, dog, you've called me too many times. Quit calling," right? It's HTTP stalker protocol, essentially, right? You
need to distinguish between failures due to rate limiting and actual errors, and do this with the error code there. Now, if the API responds to you, you have another implicit rate limit on your end.
Right. So if you have a webhook that the API vendor's calling, you need to consider what happens when they screw up and saturate your connection. Notice I said when. Not if, because somebody will eventually do this to you if you're around for very long, and especially if you have cheap equipment. Mm-hmm. You're an early stage startup like that. Those people get nailed all the time by stuff like this. What you want to do is you want to have some way of determining the number of connections that are being called, and then you throw back a HTTP 429, which means there's too many requests, and hopefully they will obey it. If they don't, oops.
Yeah. Well, now, before all of this happens, you're going to need to know how much your webhooks can take, and also consider what happens when a non-authorized user saturates your webhook, such as in a DDoS situation or distributed denial of service, if you don't know what that means.
Yeah. If it's on the open web, may get hit. Somebody may be trying to hack it, or if the calls are expensive, right? Like your call takes, 3 seconds to come back because it's intended to be called once a day. If it gets called 50 times a second, that can saturate database servers. That can do all kinds of fun stuff. I did this with a piece of code at work where it was calling 3 times a second because there was a .NET timer that was being used to dispatch the calls, and it was getting deallocated and then recreated in a spot that I didn't see, and it wasn't setting the timer interval back to like it's supposed to be.
Oh, wow.
It's supposed to be every 5 minutes, and it was multiple times a second.
Yikes.
Yeah. In services, multi-threaded, services are living out on, that was loads of fun. Let me tell you.
So next we're going to talk about when APIs die. What do you do when an API that you need is deprecated suddenly or changes to make it less useful? Sometimes companies go out of business, and that can happen without any warning.
Yeah, especially if, the government comes in and takes their machines because they've been doing something sketchy, right? There's no warning for that other than the door getting kicked in, and, it's not your building, so you don't know. And remember that if a company has gone bankrupt, your company is going to have a hard time suing them for costs incurred. You might be able to get something out of them, but it's going to be months. It's not going to fix the immediate problem.
When you are deciding to use an external API, you need to think about, what your business is going to do once it becomes dependent on that API and how it's going to recover if that API is gone.
Now, APIs can also die due to legal issues. So, for instance, GDPR changed the legal status of sharing certain data. This can make the API useless for your purposes. all of a sudden.
You might also find that the API vendor has suddenly decided that your company is immoral and shut you off.
Yeah. And I mean, you'll start to see these out there on the internet. Like, it seems like this stuff comes in waves where it's, some company decides that I'm not going to deal with people in this industry anymore for a variety of reasons. I mean, it can be, they can decide they don't want to deal with your country. They may not want to deal with, like, you're a pet store selling gerbils. Somebody out there is mad at gerbils and they own a company. Guess what? They may decide to cut your API off and you might not have a recourse for that.
Your model for working with companies should be that they're going to react to perceived risk, not actual risk.
Yeah. So if you're a Bitcoin startup, you might find that your integration with a major bank suddenly goes away.
The other thing is outages may be extended. An API may be out for a long time due to a major hack or financial, legal problems. All sorts of things could cause a company to turn their APIs off.
Yeah. Or, we get into some kind of trade war situation and they shut off their internet, or we shut it off, or some third party shuts it off because they want us to argue.
Business continuity plans need to consider external API dependencies more carefully than they really do.
Yeah. And this, by the way, is marked as being my correct opinion because it is correct and it is my opinion. Sorry. I've seen DR plans that completely ignore external APIs. And it's like, if this goes away, your business goes away and you've never thought about it.
Well, the thing is, if you don't have a service level agreement with the API vendor, you're just out of luck when they don't have stuff together.
Yeah. Realistically, you're out of luck either way. Yeah. But you might be able to sue them if you've got an agreement or something like that. So it's a little bit better.
And typically, if you have some type of agreement, you'll get more warning than if you're just using something. So finally, we're going to talk about handling multiple APIs. At some point, you'll have to handle multiple APIs to do similar things. Now, this may be because of client demand. It may be because of all the other things we've talked about and you're hedging your bets, or simply because you need features from both.
Yeah. And this adds a lot of complexity, right? Just straight out of the box, because they're not going to talk the same way. Like, one of them, you might call and send it a payload. You might do a call back later to see the progress of that payload, while the other one sends a webhook. It could be completely different processing models, completely different names for everything. They'll all have different error codes, all that stuff. It's two completely separate systems. You may be funneling into the same system, but they are not the same at the integration point. That said, with that complexity comes the ability to actually protect yourself from one of them going away. Having some kind of major problem, they pushed out a code change and it broke all the things, you can shift over to the other one. If you've got a backup, send through that for a while. And sometimes that's real nice.
Yeah. Different segments of your users are more appropriate for one API over another.
Yeah. That can be anything from, they're in this country versus this other country, right? So like, you might have a email service provider, for instance, in the US. Okay. Well, your German customers, they're not going to go for that, right? Anybody in the EU knows better to send data through the US, just in general. Like, that's not a thing that they like to do. Your US customers are going to be oblivious if you send through this company in Germany, but they may be charging more. So you may just go, okay, I'm going to use the US one, except if it's down, and then I'm going to switch it to the German one.
That makes sense.
Now, if the German one's down, you're just toast for those clients. But you can go, hey, you guys wanted this.
That kind of reminds me of, when playing some video games, you can choose which server.
Yeah. It just reminds me of, like, when Wendy's is out of spicy chicken, that I'm going to Crystal. I don't want Crystal. I want Wendy's. It's better, but I got to eat.
Yeah, I don't eat at either of those places, but
yeah.
So diagnostics also get more interesting with multiple APIs. You now not only have to determine what went wrong, but which API it went through.
And the version.
Oh,
because you may have partially rolled to a newer version, but not been able to get it on everything because now your system's so complicated. Yeah. And so V2 may be screwing up, or V1 may have started screwing up and V2 is working. Yeah. I've seen that one before too, where they roll something bad to V1 for some stupid reason.
The other thing is, if parts of your code base are poorly written.
Nobody has that. Everybody's got that corner of their code base that's the junk drawer. Like, really. Except, like some people's junk drawers have like a few spare screwdrivers and some batteries and stuff. And some people, it's their whole house.
Yeah. I agree with that. You can always tell how interesting code is going to be by how much is in the utilities or helper classes.
Yeah. So anyway, you may have code that's bad.
These problems might not surface for some time because of this bad code. And basically, it won't surface until other processes hit the data that's in question.
Yeah. So, for instance, let's say that you have multiple APIs, not multiple ones that do the same things, but multiples. Does that make sense? Like you got multiple payment processors and you got multiple email service providers and you got multiple shipping providers.
Mm-hmm.
Well, you may have something that goes, through through this one payment processor and then transits through this other email provider, and variables are changing as you're going through. And then it gets to shipping and gets screwed up. And all three APIs were involved. Let me tell you, that gets really, really ugly really fast, especially if you don't have good diagnostics, because now you're just guessing. Now, the other fun fact, and this is something I actually was talking to somebody on LinkedIn about, CRUD models can get in your way here too, right? They're kind of a terrible model for a lot of this kind of stuff. What you actually want to be able to do is either not use CRUD, use some kind of event sourcing type thing where you get tickets basically to say, here's all the stuff that happened to this instead of here's its current state, kind of like your check register or whatever versus your balance.
Yeah.
You either have to have a system like that or you have to have a crap ton of logging so that you can see exactly what happened and you can tie it to the record at its current state. In other words, you've got to be able to know, okay, this went through this email provider, not this has got a -2 in this field. Like you've got to be able to tie that in and tie it to a date range, even potentially, because you need to be able to say, okay, something started breaking, on messages that went through this one flow in the system after this timestamp. And you need to be able to do that quickly because the system is down while you're trying to figure this out.
So guys, integrating with third-party APIs looks simple on the surface, but you need to be careful about how you do it. In addition to the obvious problems, such as error handling, integrating with a third party can directly impact your system's uptime, as well as making everything more complicated. However, it doesn't have to be that way. If you plan ahead, a third-party API can make your application more capable and truly provide value. That only happens if you're well prepared. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
Well, you know how we're talking about APIs and integrations, right? You need to think about the way that systems fail. You remember playing Mousetrap as a kid, like Hasbro, that Mousetrap game, like the little board game, and you have to kind of build this Rube Goldberg machine, gets you to the end. Did you ever play that as a kid?
No, actually, no, I didn't. And that game never worked.
Yeah. Well, I played it because that was one of like 3 that we had. You need to think about error conditions like that game. For instance, your data center goes down because, somebody was talking on the phone. They stepped on a rake. It hit them in the face. They fell in the pool. It shorted out the phone. The phone sent a last message that caused a text to fire that goes over here that overloaded this server that caused a DDoS that took the data center down. There's a chain of events, however improbable, that can happen. And you have to plan for it to happen and go, what is the worst thing that could occur? Especially when it's somebody else's code and you have no visibility. That's what I'm trying to tell you here is be very, very careful always when you're dealing with somebody else's stuff because you just don't know what went into that. And I guess that's pretty much all I got.
For Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.